I'll probably have to change it anyway. What does it say right now? Wednesday or Friday or Wednesday? Okay. Okay. Perfect. Okay, so number 19. Let's get going, and then we can get done as fast as possible. Ready? Wait, hold on. There we go. Okay. So it says square root of 4x minus 3 equals 3. And this actually shows us the principle. Once the square root is all by itself on one side with nothing else except for the square root itself on that side, you can then square both sides. So this is called the squaring principle, something like that. So if you square a square root, the square root goes away. Basically, the moral of the story, and then you get that by itself. Then when you square the other side, you get 9. Then you continue as before. It's the same as it was, like the song says, or whatever. So 4x, 9 plus 3 is 12. And I forgot, what's 12 divided by 4? 3, good job. So if you had 4 people and 12 hamburgers, each person could have 3 hamburgers, right? Now, you have to check your answer because why? Because anytime you start an equation with an x inside of a square root, there's always a small chance that the answer does not work. So you just have to check the original equation to make sure it does work. So what's 4 times 3? That's 12. And then what's 12 minus 3? That's 9. So does that work or not? Yes. So that means that this answer is a verified answer, verified by the experts in algebra in the greatest college algebra class in all of fall of 2025. Now let's do number 20. So this one, it gets harder and harder and harder and harder. You ready for it? Square root 7x minus 6 minus 8 equals 0. So this is not by itself, so we have more work to do. For how do I get the square root on one side by itself with nothing else on that side? Well, I have to move the other thing to the opposite side, right? So first I'm going to add an 8 to it. And then I'll get 8 on the other side. Now it's ready for me to do the same thing that I did before. So square both sides, and then cancel out the root, and get 7x minus 6 by itself equals 8 times 2, what is that? I'm sorry, not 8 times 2, 8 to the power of 2. 64. Subtract 6 from both sides. Subtract 6 from 64, you get 58. Oh, bother. I was supposed to add it, you're right. Sorry about that. What's 64 plus 6, actually? That's a lot better, that's a lot better. So now divide by 7, and then you get 10, which is 10 times better than what I was going to get. Oh, do I have to check the answer? Yes, technically you do. So we'll go back and check it. As long as you write check down and you really did mentally check it, then that's probably good enough. So can you mentally check that in your head? What's 7 times 10? 70. And what's 70 minus 6? 64. Then what's the square root of 64? Can you do the square root of 64 in your head? 8. And then you'd have 8 minus 8, which would be 0. So that actually does check. So that's a verified answer by the greatest college algebra class of 2025, at least in this particular room. All right, perfect. 21. Let's go ahead and do that one. Okay, 21 is going to be exciting. Radical 4x plus 5 plus 13 equals 6. So we're going to have to get the radical by itself. So we'll be really radical if we do that. So that cancels. 6 minus 13, negative 7. Square root of 4x plus 5. Then we're going to square both sides. Presto. And if you square that, you get the inside of it. You square negative 7, you get positive 14. And you're going to subtract 5 from both sides. So if I subtract 5 from both sides, you'll get 54. Is that right? No, just kidding. What's 49 minus 5? 44. So 4x equals 44, divide by 4, and you'll get x equals 11. So 11's my, like, such a cool number that I probably don't need to check this, right? Do you think I really don't need to check it? Because probably it's going to work. Should probably check it. So right when you think you don't need to, that's the time when you actually do. So what's 4 times 11? Can you do that in your head? That's 44. What's 44 plus 5? 49. And who can tell me what the square root of 49 is? 7. So we got 7 plus 13. Uh-oh, what in the world? How did that happen? Does 7 plus 13 equal 6? No, so for some reason or another, that one does not work. So this one's called an extraneous solution, or basically just false. So x does not equal 11. There's actually no other solution it can have. That's the only possible solution. So if there isn't if there's only one possible solution and that does not work, then that means that there's no solution at all. No solution whatsoever. Perfect. Okay, then let's try another one. Let's try to do one that has 2 square roots in it. You ready for that? Wait, where is one though? Let's jump ahead to, okay, actually, no, before we do that, let's do number 23. You ready for number 23? So 23, by the way, let me check you in, Chad, right? Perfect. Guess what? This is actually one of the best attendances in ages. There's only one person who's not here. Rodrigo. Are you here, Rodrigo, by now? Rodrigo is great. Okay. Well, if he comes, we would have a perfect attendance. Does anybody want to like text him and see if he can come and help us have a perfect attendance? Okay, so let's see. This one actually has a different kind of radical. It has a cube root. Cube root of 2x plus 60 equals 4. There we go. Cube root of 2x plus 60 equals 4. How do you get rid of a cube root, do you think? Well, remember the kind of root a cube root is the third root. So to get rid of a third root, you need to have a third power because powers are the opposite of roots. So remember, like if you don't have enough power when you're weightlifting, remember the roots are the opposite of power, so you must have eaten too many roots. So like, just kidding. It's not the same kind of a root, but so cancel out the third root and the third power, and then you get 2x plus 60 equals 4 to the third, which is that 12? Just kidding. What's 4 times 4 times 4? 64. Now, subtract 60 from both sides. And then you get 2x equals 4. Divide by 2 and you get x equals 2. Now, guess what? Theoretically, you don't actually need to check this answer. As long as you did your arithmetic right, this answer is actually guaranteed to work if you did all your arithmetic right. The answers to the... So why do you not have to check this one necessarily? I'll tell you why, because that has a cube root instead of a square root. And cube roots have a domain of all real numbers. So that means that when you get to the end, well, they're also what's called a one-to-one function. So when you get to the end, the answer is like 1-to-1 guaranteed to work. When you have a square root, though, that's not. It does not have a domain that's all real numbers, and it's also not guaranteed to work at the end. So if you had a cube root at the beginning, you don't really have to check your answers at the end. But if you have a square root, you do. Let's try number 24. You ready for that? Number 24 is where it gets super difficult because it like really levels up. So square root of x plus 7 plus square root of x minus 5 equals 6. So at this point, you have 2 square roots. And you still have to get 1 square root by itself to start the process. So I would like to pick the one that has a little bit more stuff in it. So I'm going to get that one by itself. So how do we get that square root by itself? By subtracting the other square root to the opposite side. So then I'll get 6 minus the square root of x minus 5 equals square root of x plus 7. Right? So, by the way, notice that this negative only becomes negative in front of what you subtract. The negative inside of it does not change because that negative inside is part of the value of it. So when you move the value of x plus 5 to the other side, x minus 5 to the other side, that positive changes to negative, but the value inside of it does not change at all, though. That's just the same. Because you're subtracting the term, you're not subtracting like what's inside the term. Then you're going to square both sides. Square both sides. Now, these are the most easiest mistake is to make. Lots of people try to square it like this. They square this and they cancel it out, that's valid. And then they just try to square this, and then they just try to square this and cancel this out, and then they just get like minus x minus 5. That is not valid. Why is that not valid? You have to square the whole thing. And who remembers how to square the whole thing? How do you square, say, if you have two terms and you're squaring them as a group? Remember, how do you square a minus b? How do you square a minus b? You do a squared first, and then you do negative b squared, which is positive b squared, because if you square negative, it becomes positive. But what do you have to put in the middle, though? 2 times a times b, so with a negative. So it's like negative 2 times a times b, right? So we're going to square the 6. That's 36. But then we're going to do 2 times 6. What's 2 times 6? 12 times this negative. So that's negative 12 radical x minus 5. Then we're going to square b. So when you square b, that actually changes that negative to a positive. And when you square the square root, it gets rid of the square root. And then you have x minus 5. But this negative that's inside of it, that stays negative, just like before. So when you square the negative, only the outside negative becomes positive, but the inside negative stays negative. So that's what you get when you square those two terms. You get the square of the first term, then you get 2 times the first term times the second term, then you get the square of the last term. So make sure you don't forget to do 2 times the first term times the second term. Now we're going to get rid of a bunch of those terms. Leave the x plus 7 on the left. Leave it on the left. And then move this 36 to the left. Move the x to the left. Move the negative 5 to the left, which makes it positive 5. After moving all those things to the left, does anybody notice a pattern in which things I moved to the left? Which things did I move to the left? I moved 36 to the left, and I moved the x to the left, and I moved the negative 5 to the left, right? And they all switched to be opposite signs. What's the thing what did I not move to the left? The negative 12 radical x minus 5. The reason I did not move it to the left is because it has the radical. So I'm trying to get the radical by itself again. So basically, when there's 2 radicals, you get 1 radical by itself, and then you square it. And then after you square it, then you get the other radical by itself, and then you square it again. So you have to do 2 levels of math, like level 1 and then level 2. So you have to like level up. There we go. Now combine the like terms on the left. So x minus x is just nothing. 7 plus 5 is 12. 12 minus 36. What's 12 minus 36? Negative 24. Sweet. Wow. 12/24. That's my mom's birthday. Christmas Eve. So now what am I going to do to get the square root by itself next? What's the next step? Can I divide by the negative 12? Yep. Because it's negative 12 times the square root. So to get rid of a times, you can use divide. So divide by negative 12. What's negative 24 divided by negative 12? 2. And so you get 2 equals the square root of x minus 5. And then I forgot what to do. What should I do next? Squared. So do squared on both sides. 2x minus 5 by itself equals 2 squared, which is 22. Just kidding. What's 2 squared? 4. Then I have to do what is the last step? Plus 5. So what's 4 plus 5? 9. There we go. So x equals 9. Now, can I assume that 9 really works, or do I have to check it? I have to check it. So go back to the top. and mentally put 9 into those two square roots and see if it actually adds up to 6. Who thinks it's going to add up to 6? It's kind of doubtful, but maybe it will. So what's 9 plus 7? 9 plus 7 is 16. So you get the square root of 16. And then what's 9 minus 5? 4. So it's square root of 16 plus the square root of 4. And what's the square root of 16? 4. What's the square root of 4? 2. So you have 4 plus 2, so it does equal 6. So that one actually does work. So barely. It works though.
Where did you get the 2 from?
The 2.
To square it.
To square it. So basically, when you get to this next step, 2 by itself equals the square root by itself. That's the step where you have to do something to both sides. So this 2 right there.
What about the negative 24?
That would be the positive 2. Yeah. So negative 24.
Got it.
Yeah.
Okay, got it.
Yeah. So we're just dividing by the negative 12 because it's in front of the radical. Yep. Okay, perfect. Now 25. So day after December 24th is December 25th. So we have Christmas almost to look forward to. That's incredible. Actually, 25 is easier because 25 only has one radical. Should we do it anyway? Who wants me to do it anyway? So do 25, even though it only has one radical? Yes, okay. So let's do 25 because we wouldn't want to be the Grinch that stole Christmas. So 2 square root 4x plus 5 minus 7 equals x minus 2. So we're going to have to move over the negative 7 first. So add 7 to both sides. Then we'll get 2 radical 4x plus, by the way, if you have 2 radical, that means you're 2 radical. So 2 radical 4x minus 5 equals x plus 5. So how do I get to the next step after getting to this? What do I do to get divide by 2? Correct? Well, this is going to be a fraction. This is terrible. Radical 4x minus 5 equals x plus 5 over 2. Sweet. Well, not so sweet, but it's okay. So after I do that, then what do we do next? How do we get rid of a radical of a squared root of a square radical of a square, a square root radical? How do I get rid of a square root radical? By a power of 2. Yep, by squaring it on both sides. So square root of a squared crosses out. So we get that by itself. Then when you square that side, well, this is going to be tough. Square the top. What do you get on top if you square x? Remember, what do you do if you have 2 things and you square a and b? You get a squared, right? Plus, then you multiply the 2 times a and b. So what's 2 times 5? 10, and then times that. What's 10 times x? And you keep the sign from the middle, so it's 10x. Then you square b, so what's 5 squared? 25, right? Now we square the bottom. So the bottom of it is also inside the power of 2. So what's 2 to the power of 2? 4. So we get x squared plus 10x plus 25 over 4. Now we're going to cross multiply. So we're going to take the bottom of this side times the top of that side. So take that 4 and multiply it times the top of the other side. So what's 4 times 4x? 16x. And what's negative 5 times 4? Negative 20. So 16x minus 20 equals x squared plus 10x plus 25. Say what? Positive 5. Oh, you're right. Yeah, because, okay, so my original number doesn't change. I just dropped the net positive the whole way through. Sorry about that. Good point. You're right. So what do I do next to get it by itself? So the reason that the difficult part of this problem is not the square root, actually. There was only one square root. It was easy to get rid of the square root. But now we have what kind of equation do we have? This is really like a review. This is a quadratic equation, right? So how do you solve a quadratic equation? take it all on one side. So we're gonna have to get rid of the left side by subtracting it from both sides. Then we have 0 on the left side equals x squared minus 6x plus 5. Wow. How do I solve that equation? Factor it. So, wow, this is boring. So I keep the sign from the first one the same. Multiply that sign times that sign, you get another negative sign. Then you multiply the first number 1 times the last number 5, which is just 5. And then how about 1 and 6? No, 1 and 5, 1 times 5. And I put the 5 in the one, that one, and the 1 in that one, that adds that makes negative 6, which equals the middle. So does that look correct? Now, what are the possible answers? The opposites of those numbers. So the possible answers are x equals positive 5 and x equals positive 1. Then we have to check both of them. I hope that they don't work because I don't want to have two answers, but let's try 5. 5 plugs in, 4 times 5 is 20. 20 plus 5 is 25. What's the square root of 25? 5. What's 5 times 2? 10. What's 10 minus 7? 3. But they don't have 3 on the other side, they have x minus 2. So we also have to plug 5 into that side as well. So what's 5 minus 2? 3. So we get 3 on that side and 3 on that side. So unfortunately it works. I kind of like it when they don't work because then you don't have to type that answer in the box. How about 1? Maybe that one probably does work, right? So we have to check it anyway though. So 1. What's 4 times 1? 4. What's 4 plus 5? What's the square root of 9? 3. And then what's 3 times 2? 6. And what's 6 minus 7? -1, right? So it can't work if it's negative, right? Well, it doesn't matter if it's negative. That's not what makes it work or not. Let's try the other side. So put 1 to that other side. What is the 1 minus 2? -1 as well. So yikes, they both worked. It's not fair. So both answers, because -1 does equal -1. So in this case, they both worked. That actually usually doesn't happen. Usually if there's two answers, one of them doesn't work. But in this case, my prediction was wrong. So both of them actually worked. That's crazy. Okay, let's try to do a rational power problem. Does that sound exciting? Rational power problem. Let's do 26. 3x plus 1 to the 1/3 power. By the way, a rational power problem is actually a radical problem that's disguised. So what's it? Radical problem that's disguised. Like if you're sick of guys, does that mean you're disguised? So 3x plus 1 to the 1/3 power plus 1 equals 3. It actually is a radical problem. Does anybody know what kind of a radical problem it is? What does the 1/3 power actually represent? A cube root, right? But actually, though, we're not going to write it as a cube root, even though that's what it is, because when you have a rational power, it's actually easier to solve a rational power than it is to solve a radical. So all you have to do is get the rational power term by itself. So how do we get that term by itself? Minus the 1, correct. So then you get 2. 3x plus 1 to the 1/3. Now the question is, how do you move a rational power to the opposite side? Once you have it by itself, it's really cool. All you do is you flip it over. So flip over that power. Boom. Then you move it to the other side. So with powers, when you move a power to the opposite side, it does not become negative. Instead, it becomes flipped over. So you get 3x plus 1 equals 2 to the 3/1. And now what is 2 to the 3/1? Well, first of all, what's 3 divided by 1? 3. So we get 2 to the 3 equals 3x plus 1. What's 2 to the 3? Is it 23 or something else? What's 2 to the 3? 8. Smart. 8, that was great. By the way, if you go to the after you go to the cafeteria, then you have 2 to the 3 because you ate. So subtract 1 and you get 3x equals 7. No, this is impossible, so just kidding. Divide by 3, x equals 7 divided by 3. Now, technically, this answer is guaranteed to work unless you made a mistake in the arithmetic. So I could have made a mistake though, but if I didn't make a mistake, then this answer is guaranteed to work. Why is that? Because that's a cube root, and a cube root does not have any restrictions on its domain, and that's also what they call a one-to-one function. So that means any solution that you get from it is guaranteed to work in the original problem. But we can still check it if you want to, but you'll have to though. So I just feel like doing it though. So here's 7/3 plus 3 times 7/3. That'd be 21/3. 21/3 is 7. What's 7 plus 1? 8. What's the cube root of 8? It's 2. 2 plus 1 equals 3, which equals 3. So it actually does work. So 27. Okay, are you ready for another one with 2 big bad square roots? Okay, 27. This is the test to see if you this is to test your mettle in math. You know what that means? There's a word metal, which means like this is like metal, but there's also the word called metal. What does that word mean? That means like how worthy you are in math. So what is your mettle in math? Well, let's find out. Square root of 4y plus 20 minus radical y minus 4 equals 6. Radical 4y plus 20 minus radical y minus 4 equals 6. Okay, there we go. Now, how do I solve it? I need to get one radical alone. So I always recommend getting the bigger radical alone first. Let's get the bigger one alone first, because that way you're not dealing with that big radical the whole rest of the way. Move this radical to the opposite side, so you'll have 6. Then what do you have after the 6? What we have? Well, we have a negative or a positive? Positive, yep. Positive radical y minus 4. And then I can square both sides. So square that side, square that side. So on this side, the square cancels out the square root. Boom, boom. 4y plus 20 equals. And then when you square a group of 2 things, you first square the first thing. So what's 6 squared? 36. Then you multiply the power of 2 times the first thing times the second thing. So what's 2 times 6? 12, positive 12 times the second thing, which is y minus 4 in the radical. Then you have to square the last thing. So what happens if you square the square root of y minus 4? You just get a positive y minus 4 by itself. So there's that. Any questions? Perfect. You guys are so smart. Good job. Do you feel smart? For some of you. Okay, so, but I'm glad that some of you also feel smart though as well. So, wait, I'm feeling dumb. What do I do next? What's my goal? I forgot my goal. I have to get the other square root by itself. So I'm going to circle that thing. I'm going to leave it where it is, but I'm going to move the 36. Let me use pink so it's easier to think. Move 36 and move the y and move the negative 4 all to the opposite side, right? So it'll be 4y plus 20, and then I'm going to have negative 36. Then I'm going to have negative y. Then I'm going to have positive 4, like that. So move all those pink things to the left side. The only thing left on the right side is 12 radical y minus 4. There we go. Perfect. Now we need to combine the like terms on the left. So 4y minus y is 3y. And then what is 20 plus 4 minus 36? What's that? You do all three at once, maybe, if that's not too much. What's 20 plus 4 minus 36? Correct. Good job. So 312. Perfect. Anything special about 312? Probably somebody's birthday. Does anybody have a birthday on 312? Wait, is it anybody's birthday today? Oh, tragic. Has it ever been anybody's birthday? Didn't we have one time I have a birthday in class? Maybe not. Oh, that's too bad. Well, happy late birthday to you. Thank you. Okay, I'm stuck. What do I do next? Divide by 12? Okay, good job. Divide by 12. Boom, boom. So then we get 3y minus 12 equals 3y minus 12 over 12 equals radical y minus 4. There we go. Then what? What do we do next? I forgot. Actually, wait, before I do anything else, can I reduce that fraction on the left? Doesn't 3 go into everything? So before I do anything else, let me reduce it. So what is 3y minus 12 divided by 3? It's just y minus 4. And what is 12 divided by 3? 4. Good job. Now I'm ready to square. So now should I square both sides? Uh-huh. So I put a power 2 on both sides. Good job. You guys are so awesome. Literally so awesome. Okay. Square root of y minus 4 squared is just y minus 4 by itself, right? And then I'll do the bottom first of the left side. What is 4 squared first in the bottom of the left side? 16, correct. Now the hard part is the top, because how do you square a group of two things? What do you do to square a group of two terms? Well, you first square the first term. So what's y squared? It's just y squared. Then you have to do the power of 2 multiplied by this term and then times this term. So 2 times -4 makes -8, then times y. So it's -8y. -8y. The last thing you have to do is to square the second term. The -4 squared is -4 times -4, which is positive 16. So we get a positive 16 on the top. Boom. Oh, that's terrible. But now what we're going to do is we're going to cross multiply this 16 bottom of the left side times the top of the right side. So we're going to take the 16 and we're going to, can you even see this arrow because it's yellow? Okay, we're going to take that 16. Let me change it to a different color. How about green? So it can be seen because green rhymes with seen, sort of. Oh, sure. So multiply 16 times the right side. And then, wow, this problem is proving our metal more than I thought it would. So on the left side, we'll have y squared minus 8y plus 16 equals 16. Okay, what is 16 times y? 16y. Then what is 16 times -4? Oops. Yeah, you're right. I wrote -32 first, but yeah, I'm wrong. You're right. Okay, I didn't have enough space for it. 16 times -4 is actually -64. Wow. Barely enough room for that. So can you see that -64? So I guess, so what kind of equation is this? Quadratic. How do I solve a quadratic equation again? By moving everything to one side. So I need to subtract the 16y and I need to add the 64. So let's do that. So let's subtract. Take away 16y from both sides. And then let's add 64 to both sides. So if I do that, I'll get y squared minus 24y, which stands for why, oh, why am I doing this problem? Plus 16 plus 64 is 70, 80. 80. What if your name was like Grady and your number was 80? It could be 80 to Grady or Grady the. How do I factor this out? By the way, did you know nobody on our football team is number 28, I think, is that right? which is sad because 28 is a perfect number. So y squared minus 24y plus 80 is, how do I factor it? Well, y squared becomes y times y, bring down the negative sign, multiply the negative times the positive is another negative, and then multiply the 1 times 80 and get 80 to Grady. And then factor out 80 to be two numbers that add up somehow to make 24 with a negative in front of both of them. So any ideas? How about 10 times 8? No, that wouldn't work. How about 5 times 16? Would that work? No, how about 4 times 20? Wait, that would work. 4 and 20. 4 and 20 blackbirds baked in a pie. Have you ever heard that song? You've never heard that song? It's like a fairy tale. 4 and 20 blackbirds baked in a pie. I forgot the rest though. So multiply. And then you get y equals 4, y equals 20. And then we have to check to see if they work. So let's check them. This is hard. Wow, this is really hard. So plug 4 in. 4 times 4 is 16. 16 plus 20 is 36. 36. So that's the square root of 36. 6. So 6. Now plug in 4 into that one. 4 minus 4 is 0. So get 6 minus 0. What does 6 minus 0 equal? 0. No, wait. 6 minus 0 equals 6. So it's correct. So 4 works. I hope the other one doesn't work. It does work. Oh, okay. So 20 times 4 is 80. 80 plus 20 is 100. Square root of 100 is 10. And then 20 minus 4 is 16. That's square root of 6 is 4. 10 minus 4 is 6. It works. Nuts. Wow, these just work too much. Okay, perfect. Okay, well, finally we're done with those. Are you excited about that? We get to learn something way more easier and way more fun. Ready? So do you like to be yourself? So I equals cool, too cool for school. Actually, I actually represents -1 to the power of a half. Why is that important? Because guess what? If you take one I times another I, you get one -1 to the half of a power times another -1 to the half of a power. What happens if you multiply two half powers together? You get a whole power. And you add the powers together, 1/2 plus 1/2. So what is 1/2 plus 1/2? 1. And what is -1 to the first power? -1. So basically, why is this super important? Because guess why? Because now, what's the square root of a number like -9? All the way up until now, we always said it was actually a little bit of a white lie. We said you can't do the square root of -9. But actually you can though, because the square root of -9 is actually 3i. Guess why? Because like all square roots, when you multiply 3i times itself, you get, what do you get when you multiply 3i times itself? You get 3i squared. No, not 3i, sorry. My fault. You don't get 3i squared. What do you actually get? What's 3 times 3? 9. You get 9i squared. And what is 9i squared? Well, we just said I times I equals -1. But another name for I times I is just I squared. So actually I squared equals -1 as well. So 9i squared is just 9 times -1, which is -9. So that means that actually 3i times 3i equals -9. So that means it's actually true. -9 does have a square root, and it's equal to 3i. So from now on, any negative number does have a square root. It's just the square root of what it would be if it was not negative times the letter I. So let's go crazy with that. Ready? Square root of -25. What's the square root of -25? 5 with an I. Sweet. Okay, let's raise the difficulty level a little bit more though. That's problem 30. What's the square root of -75? So we have to break the square root of what does 75 break down into? 25 times what? 25 times 3. And wait though, what does the negative mean? When you do a negative number in a square root, you get the same square root if you just didn't have the negative. But then what do you have to put on the outside though? An I. So take out the negative by putting an I on the outside, and then break down the 75 just like normal. What's the square root of 25? And then what's the square root of 3? Irrational, so you can't do it. So the answer is 5 radical 3 and then I on the outside. Make sure you don't put I on the inside though, because then you'd have the square root of I, which would be really weird. So make sure the I is on the outside. Okay, let's try to do 3 more questions. Ready? We've learned
11:46.
I know, but we need to learn how to add and subtract. Or maybe just 2 more problems. So let's add 32, 9, subtract, and I times 3 plus I. How do you add numbers with I in them? All you add the like terms. So 9 and 3 are like terms. What's 9 plus 3? 12. And then 8i and I, those are like terms. So if you had 8 i's plus 1 more I, how many i's would you have? 9 i's, right? Wow, that'd be crazy. 9 i's. Would that be like an octopus or something? No, I don't know. And then, so we learned how to add. Now let's learn how to subtract. While you guys are having. Well, you had it hard before, but now it's easy. Yes, 5 plus 5i. So how do you subtract with I? Just like normal, basically. So subtract the like terms. So what's 3 minus 5? Negative 2. And what's 9i minus 5i? What's 9i minus 5i? It'd be 4i, right? There's one tricky thing though. Make sure that if you have a double negative that you do it as a positive. So if it's like a minus, and then if it's another minus, what would it be if it was like minus a minus 5i? Then you'd actually add 5i. So we did 2 more questions. Unfortunately, you won't be able to learn to multiply today yet though, but tomorrow, on Wednesday, we can look forward to multiplying and dividing. That'll be exciting. Because exciting rhymes with dividing, I guess. So by the way, once we're done with Wednesday, then you're gonna have fall break on Thursday and Friday, right? Yes, I think, yeah. Yeah, because we only have like 5 more questions to do, or like just a few more. Yeah. Yeah, but I think the test is on Thursday though, I think. Or well, the test is whenever, like it's not on Wednesday though, like later. So it's not that bad. I could possibly even push the test back a little bit more. Okay, ready? So good job, everybody. You guys are awesome. Hopefully you'll have the most funnest fall break ever in the world. Keep up the good work. Thank you. Yeah, we still have class on Wednesday. I'm sorry, I shouldn't have said it yet, but after Wednesday, then you can have fall break. The funnest fall break in the world after Wednesday.